Hello dear students, welcome to lesson 5 on structure of atom on the channel Learning Chemistry is Easy and Fun. Today's topic is electromagnetic wave theory. Now this sounds very long, so let's break it down. What does the electromagnetic wave theory say? Now first of all, wave. What is a wave? Wave is nothing but a mode of transport of energy from one point to the other. So when we strike an object, the sound is reaching you in the form of waves, right? So these waves can be light waves, sound waves, any, but specifically we are talking about those waves which do not require a medium to propagate. Waves which require a medium to propagate, like the sound wave, are known as mechanical waves. We are not talking about mechanical waves in this particular lesson, although the characteristics of the wave remain the same. So we are talking about the electromagnetic wave. So we're not talking about the mechanical waves today, we're talking about the electromagnetic waves. Now let's break it down. So wave, we said, mode of transport of energy from one point to the other, or simply put, energy gets transmitted from one point to the other in the form of waves. Now, electromagnetic waves. What are these special waves? They are waves which are associated with an electric field and a magnetic field. Basically, charged particles, when they move through space, generate a magnetic field, and interaction of that electric and magnetic field gives you the wave, and these three are mutually perpendicular to each other. So we have the representation over here in the form of three colors that I have. So what we have over here is the electric field, the magnetic field, and the direction of the propagation of the wave. That is how the three are mutually perpendicular to one another. So electromagnetic waves do not require a medium for propagation, and they are always associated with an electric and magnetic field wherein the three are mutually perpendicular to one another. Another interesting property of electromagnetic waves is they all travel with the same speed, 3 into 10 to the power 8 meters per second. This, if you can relate to, is also the speed at which light travels, right? So we have the electromagnetic wave theory. Now, when we talk about the wave, we're talking about the characteristics of wave. How do we represent a wave? Simple. If you want to observe a wave, go to the nearest water body, say a lake or a pond, and throw a stone in that. So you see these ripples forming up, down, right? These ripples are the representation of the waves, right? Here we have graphically represented the movement of a wave. This vertical y-axis represents the displacement. The horizontal talks about the distance. This we are talking about on the x-axis is the distance being represented. When a wave moves, there are points where it is away from its mean position. So this line that we have drawn, the x-axis, represents the mean position of the wave. When it moves so that it is at maximum distance from its mean position, is what we call as crest. When it is maximum distance from its mean position but in the opposite direction, then it is called as trough. It is just like I have a pendulum over here. The pendulum moves left and right. So if I consider this direction as positive, then this direction becomes negative. It can be vice versa, but by convention what do we do is the points above this line become positive, the points below this line become negative. Why we are giving these signs is because we are talking about displacement. It's a vector quantity. We're talking about a specific direction. So the point of maximum positive displacement is crest. Point of maximum negative displacement is trough. So if you notice, I have one crest here, another crest here. So as the wave advances, there will be more crest and troughs. Distance between any two consecutive. The word is consecutive. Consecutive means coming one after the other. Distance between two consecutive crests or two consecutive troughs is what we call as wavelength. Same way, the distance between these two particles, you see, they are advancing in the same direction. So they are in phase, they are in the same phase. This can also be represented by wavelength. Distance between this and this particle also makes one wavelength. So representing one wave. Distance between two consecutive crests or between two consecutive troughs is what we call as wavelength. It is represented by the symbol lambda. Because it's distance, we can represent it by meters or centimeters. Now, electromagnetic waves comprise of waves which have varying wavelengths. Now, on the basis of their wavelengths, the electromagnetic spectrum has been divided into R, M, I, V, U, X, G, C. This is my short form for the electromagnetic spectrum. This is my way of revising or remembering. You can devise your own mnemonics over here. What do we mean by over here? R is for radio waves, micro. So we have radio waves, we have microwaves, we have the infrared rays, we have the visible part of the spectrum, that's what we are able to see. You have the ultraviolet rays, you have the X-rays, the gamma rays and the cosmic rays. Now these are arranged in the decreasing order of their wavelength. So what is happening over here is the wavelength is decreasing in this order. Wavelength decreases over here. So R, M, I, V, U, X, G, C. Radio, micro, infra, visual or visible, sorry, ultraviolet, X-rays, gamma rays, cosmic rays, right? Now, let's also talk about frequency. Number of waves passing through a point per unit time. So, we have one here. On the other hand, if I have a number of waves passing through this point, so the frequency of this will be higher, right? So, how many waves are passing through a point per unit time? Obviously, when I increase the frequency, the wavelength actually decreases. So, if I have more waves passing through this point per unit time, the wavelength is actually going to decrease, right? So, now the wavelength is this. In other words, frequency increases, wavelength decreases. So, if I have arranged the electromagnetic spectrum in the decreasing order of wavelength as R, M, I, V, U, X, G, C, then in the order of increasing frequency, it will be R, M, I, V, U, X, G, C. From this, we know that if wavelength is increasing, the frequency has to decrease. Right? So, if you are asked to state the components of the electromagnetic spectrum in the in the order of decreasing wavelength, then it is this. If you are asked to state it in the form of decreasing frequency, then how will you state it as? Can you make a guess? Probably write it down and see if your answer tallies. I'm talking about decreasing frequency. Yes, it will be the reverse. CGX UVIMR, because we're talking about decreasing frequency. We're not talking about increasing frequency. Later on, we will also study that the energy of these waves is also associated with this frequency. That we will do later. But just to give you an idea at this point, and you will be able to correlate as well, because the energy is related to frequency. As the frequency increases, the energy will also increase. That is why you find the X-rays, gamma rays, cosmic rays are much more dangerous and harmful compared to the radio waves, the microwaves, which we are using almost daily with no susceptible harm to us. Coming to wave number. Wave is the number of waves present per meter. Now, if you see over here, we have specified over here the number of waves per meter. That means it is the reciprocal of wavelength. So, nu bar is the symbol which we use for wave number. This is equals to 1 upon lambda. So, that means this is 1 upon meter, gives us the unit as per meter. Amplitude we have done, it is the point of maximum positive or negative displacement from the mean position. So, we know that the electric field, magnetic field are moving around this. So, what we have is the point of maximum positive or negative displacement. This gives me the amplitude represented by A. Time period. When you talk about a pendulum, time period is time taken to complete one oscillation. Simple. So, that is how we will represent time period. So, this is one oscillation or one wave. Correlating frequency and time period. We say frequency is the number of waves passing through a point per unit time, and time period is time taken to complete one wave. If there are new waves passing through a point in 1 second, that means one wave is taking how long? Yes, apply the unitary method over here. If 10 pencils cost 1 rupee, then 1 pencil will cost how much? Right? So, we have 1 upon nu seconds over here. This gives us what we call as time period. In other words, your time period and frequency are inversely related to one another. That is why the unit of frequency is taken as per second, or this per second is also written as hertz, H-E-R-T-Z, represented as capital H and small z. This is what we call as the unit of frequency, per second or hertz. Now, we know about crest, trough, wavelength, wave number, amplitude. We need to study the wave velocity. How will you define velocity from your knowledge of physics? Yes, it is the displacement per unit time. That is what we talk about. Now here, displacement is what is represented in meters, time is in second. So, the wave velocity is meters per second, as simple as that. Now, let's convert this formula into the terms that we have learnt just now. In one time period, that is capital T, how much is the distance covered? What value out of these gives you the distance covered by the wave in one time period? Yes, it's the wavelength. So, lambda upon t. So I have another formula. Wave velocity is the wavelength divided by the time period. Now lambda, I can also write it as this. Doesn't make a difference, correct? It is still in the denominator. Now, what did we derive 1 upon t as just now? Yes, you wrote t is 1 upon nu, or nu is 1 upon t. As simple as that. So what do we have over here is 1 upon t can also be written as frequency. So we have got velocity. Wave velocity is given by the distance upon time, or it is given by the wavelength into the frequency. So we have derived another formula for the velocity of a wave. Right? You can use either of the formulas. Now, the target for you is to attempt numericals based on this. Be very, very careful of the units. See, the numericals based on this topic are very easy. You can get hold of any reference book and go step by step. Whenever you are attempting a numerical, there are certain things that you have to be careful about. When attempting a numerical, first, read the question carefully. So, my first point that we will do is to read the numerical. Second, what do is, we jot down the values which are given to us. What is given to us, whether frequency is given, wave velocity is given. Third, I see what is to be calculated. What do I have to find out? So let's suppose I have to find out the wavelengths. I'll put wavelength is what? Fourth step, and very, very important step in getting the numerical correct, is to check the units. Make sure that if you are taking velocity in meters per second, then your wavelength is also in meters, or your time which you are taking is also in seconds. So your frequency will be in per second. Very, very careful about your units. Fifth step in doing any numerical, not just the numericals of this topic, is to write the correct formula. You put down the values, and I can bet that there is no way that you will get your numerical wrong. So first, read the numerical. Second, jot down the values which are provided to you in the question. Next, jot down the value that you have to find out. So you put a question mark. Check the units. Make sure that you are following the same system of units. So if it is the SI system, it's the SI system. So meters, kilograms, seconds. Then is the formula. You write down the formula, jot down the values, and do your calculations. Please, I request you to attempt at least 10 numericals based on this topic, and then you will never have to even revise this topic. You will be so thorough, and you will be able to even teach it to any student or your any peer group. If you've liked the video, please don't forget to subscribe to the channel. Learning chemistry is easy and fun, and sharing is caring. Don't forget to share it with your friends. Happy studying, all of you. See you in lesson 6.